Hello and welcome back. This is the intermediate track of the Beam College. This is session 6, the final session for the intermediate track, and I am your presenter, Dr. Carrie Donnie Clark. So we've been going over in this intermediate session implementing a complex machine learning pipeline in Beam Python. We talked about the run inference transform that makes machine learning easy, the model handlers that let you use a variety of frameworks. We talked about choosing models and how to adapt them to Beam, a high-level overview of the example pipeline we're using, and then a deep dive into the pipeline code and how to actually construct a complex ML pipeline in Beam. And we got to see it running live successfully end to end. So now we're going to zoom out a little bit and talk about how we can go from this basic example pipeline to solving real-world problems. So our pipeline follows this fairly simple pattern of doing some inference, using a classifier to then send data to different models, and collecting the output of those models and then doing another transformation or another inference on the output, assuming that all those models are essentially fine-tuned. They accept the same inputs and give the same outputs, but they're fine-tuned to different use cases represented by those different classes of data. So we did it for a fake set of phone calls for a help center, very formulaic and specific, transforming them to text, classifying them, running inference, getting some amusing replies because we don't actually have fine-tuned models, and then turning that back into voice. And we can demonstrate this pipeline runs successfully, even with relatively constrained hardware. So let's think about how this pattern could solve other business problems just by changing the models and the model handlers and the data that flows through the system, but without really changing the graph or the approach. So let's consider an e-commerce situation where when a customer visits your site, you can pull their history, their browsing history or their purchase history from your database. So you have some object with customer history in there. And then let's say you feed that to a model that's going to cluster that customer based on that history data with other similar customers. So you're going to get a class or a group. And then let's say you take that group based on similarity of purchase history or view history, and then you're going to use that data and that grouping to segment further by demographics. And so now you have demographic clusters that are also representing different purchase histories. You could then send those to a fine-tuned recommender model for that purchase history and demographic. And what this lets you do is say, oh, people who are millennials who have recently bought a coffee machine are going to frequently next buy a broom. And you can have a very fine-tuned model that says, when a millennial who's recently bought a coffee machine comes to our site, we want to then recommend for them on the front page a broom, because we think that's the most salient item to display to convert them to a sale. So this is the exact same topology of graph. But you can see by changing the models and the data, you could get something that is of limited value, something that could be much more valuable to your business. And taking the pipeline we wrote and turning it into this pipeline is relatively speaking, a very small amount of work instead of trying to orchestrate your own pipeline to do the same thing. It's surprising the amount of efficiency you can get from this. Another example with the same graph topology would be for content moderation, where you could say, I have a platform that users can post to, and I'm an international platform. But it's very hard for me to have good representation of all languages in my models for things like spam or abuse. So I could say I take users' posts, and the first thing I do is I translate them into a common knowledge where I have the strongest models with a machine learning model. Then I take that common language representation and I use that to classify what kind of post this is. Then, and let's say that could be, I classify it, is this a post about news? Is this a social post? Is this a post about given media personality? Is this a post about current events? I can classify it because those look very different and there are different standards in different kinds of posts or different kinds of communities. You can probably say something in a community of music fans and probably use rougher language than you would in a community of university professors, for example. And so you want to be able to moderate appropriately. So you classify the type of post and then you send it to a model that can scan for abuse based on the class of post. This lets you be much more nuanced or subtle. You don't take down song lyrics in a music group, even though those same words in a news group would be inflammatory or would be spam or abuse. So having that fine-tuned model per kind of post could be very valuable. And then the output of all these models, though, is the same. It's a recommendation for what you do with the post. Do you allow it to be posted? Do you filter part of it? Do you warn the user? Do you ban the user? All of that, all these different fine-tuned models can take the same input and provide the same output. But because they're working on a smaller class of data, they can give a more accurate, tight output. And you can adapt that. If you get a new class of post, you can train a new model to deal with it. Another way you could use this is you could think of this as a generative pipeline. The user gives you a prompt, something they want your system to do or make. Again, translating to a common language as the first step is something you have to do in many global contexts. And machine learning models are the strongest way to translate but keep fidelity to the user's original intent. Once you have that common language, you can use a more powerful, more accurate classifier. So say the user is prompting you to do something. You might use this to say, what do they want as output? Do they want text output? Do they want a song as the output? Do they want a picture as the output? Do they want computer code as the output? You give them the ability to write free text. You classify it with a classifier so that then you can feed it to the appropriate model. And this lets you save on model size. This is more of like essentially a mixture of experts kind of approach, where if someone wants text, you send it to the text generative LLM. If someone wants code, you send it to the code generative LLM. If they want a picture, you send it to the visual generative LLM. And by having those be separate models, you can be smaller and more efficient models that can produce higher quality output for the same computational resources, as opposed to having a giant model that can take any input and produce anything. But still, these are all producing file-shaped output, right? They're producing a WAV file for music, a text file for text, PNG for a picture. So it's still the same input to the generative model. It's text input to a different model that can produce a different kind of file output that's appropriate to the request. Now, these are all examples that have the same topology. But a beautiful thing about Beam is that you can represent any directed acyclic graph of operations and run it in Beam. So you could run something much more complex. And what these ML functions allow you to do is take a graph like this that has deep complexity and add machine learning inference to any arbitrary node. And again, that's quite powerful because that could allow you to collapse several nodes into one, or it could allow you to add nodes that can improve your output or increase your filtering capability, or do all of the many, many, many things that powerful machine learning models are starting to allow us to do. So the nice thing is, if this was your Beam graph, adding machine learning to any of these transforms, or adding a new node with a machine learning operation in it for inference, is very straightforward. And we expect to continue developing more and more machine learning transforms and to make more and more steps of deploying and managing a machine learning model in your pipeline easy and straightforward. So I hope you've learned a lot. I really appreciate that you have stuck with us through six sessions of Beam College Intermediate. And of course, we've talked about a lot of different notebooks and sites and models, and that information is all in the description of these videos. So click away, copy, try your own models, and of course, comment, let us hear back. And we are always accepting contributions directly to Beam. We're an open source project as part of the Apache Foundation. And so if you think there's something missing, we are happy to help you contribute it. All right. Thank you, everyone. I appreciate your attention. Now go forth, write pipelines, and do something interesting. Thanks again. I'm Dr. Cary Downey Clark, and it's been a pleasure. Bye-bye.